Today I'll be teaching the topic isotopes. Let's begin. There are certain elements which have the same atomic number but different mass number, and those elements are called as isotopes. Let us consider the following example. Protium, deuterium and tritium, they have the same atomic number of 1 but different mass numbers. Protium has a mass number of 1, deuterium has a mass number of 2 and tritium has a mass number of 3. Therefore, protium, deuterium and tritium can be considered as the isotopic forms of hydrogen. The other examples of isotopes include carbon-12 and carbon-14. Both of them have the same atomic number, that is 6, but different mass numbers 12 and 14 respectively. Similarly, chlorine-35 and chlorine-37 have the same atomic number, that is 17, but different mass numbers 35 and 37 respectively. Therefore, isotopes are defined as the atoms of the same element having the same atomic number but different mass numbers. Many elements consist of mixtures of many isotopic forms. Each isotope is a pure substance. The chemical properties of the isotopes are similar, but their physical properties are different. Now the question arises, if an element has many isotopic forms, then what should be considered as the mass of the atom? The average atomic mass of the chlorine atom can be calculated in the following manner. You already know that chlorine has two isotopic forms, that is chlorine-35 and chlorine-37. So the average mass of the chlorine atom can be calculated in the following manner. The two isotopes of the chlorine have the atomic mass of 37 and 35 in the ratio 1:3. So, the average mass of the chlorine can be calculated in the following manner, and it comes out to be 35.5 U. If an element has no isotopes, then the mass of its atom would be the same as the sum of the protons and the neutrons in it. If you take certain amount of chlorine, then it would contain both isotopes of chlorine, and the average mass is 35.5 U. This does not mean that the average mass of a single atom of the chlorine is 35.5, but it means that if you take certain amount of chlorine, then it would contain both the isotopes of chlorine, that is chlorine-35 and chlorine-37, and the average mass of that amount of chlorine would be 35.5 U. Now let's move on to the applications of the isotopes. An isotope of uranium is used as a fuel in nuclear reactor. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter. And there are many more applications of these isotopes. Thank you.